Good evening to all. I welcome you all to today's NVIS webinar topic, Know Your Wildlife Corridor by Dr. Gopala Arindran. I would like to take few minutes to introduce our today's speaker. Dr. Gopala Arindran is the Director of Indira Gandhi Conservation Monitoring Center at WWF India. He has more than 25 years of experience as a professional and leader in geospatial technology and has been the driving force of location-based data monitoring and analytics since 2001 at WWF India. His work at WWF ranges from addressing conservation issues occurring in various landscapes with a high focus on tiger, elephant, and rhinoceros to overseeing several institutional GIS-based projects. He has led the core technical team with WWF India to utilize current generation technology and has always been a partisan for applying GIS solution to overcome challenges within the field of conservation. Being an integral part of the WWF network, he has participated and overseen various international projects from understanding the impact of global forest fires, deforestation, and degradation to capacity building programs on GIS and remote sensing for staff at WWF Bhutan. Recently, he has spearheaded WWF India's geospatial and analytical contribution to UNDP's Secure Himalaya project and is the current coordinator for the Green Skill Development Program of MOFCC, Government of India, wherein he has been regularly conducting GIS-based skill development trainings for youth. He has published several research papers and reports in peer-reviewed journals and is involved in publication of 4 books in the capacity of an editor and co-author. And as a pioneer of geospatial education, he has also supervised over 100 masters and research students. And I hope today's webinar is going to be very insightful. And I'd like to hand over this session to Dr. Arindran sir. Over to you, sir.
Yeah, thank you. Thank you very much for the introduction. So today's talk is going to be on how to use the technology, especially remote sensing and GIS in mapping the corridors and how the corridors are impacted. What is the level of the fragmentation happening in the corridors and what's the size of a corridor? So I'll be talking about one of a project which we did for the government of Madhya Pradesh. And WWF jointly in Pench and Tiger, which is a tiger reserve in Madhya Pradesh, and Satpuda is also another tiger reserve. So there's a corridor existing between them, and the animal, like mainly tigers and the prey species are moving between them. So we wanted to understand what's happening with the many research projects are happening in that area. It's also been disturbed by open mining. So we wanted to understand what is the status of the corridor there, how land use, land cover has changed in the last 15-20 years, and what is the present status, and we use a few techniques using GIS to understand what is a possible path for the animal to move, and how we can address the issues like some fragmentation has happened in certain areas. Using conservation effort, how we can do some plantation work to bring back the cover, especially in those corridor areas. So that's the focus of my talk. So the introduction, I would like to. It's a given. It's a location in Madhya Pradesh, the district of Sivni and Chhindwara. Both the park is located, and it across the corridor is lie between the the Sivni district as well as it crosses through the Chhindwara district and reaches the Satpuda Tiger Reserve. So between the two tiger reserves, it actually, and it's one of the why do you need to study a corridor? It's one of the important is that the tiger population, when they move across both corridors, for there is a lot of genetic exchange which happens, which is very very important part of the tiger population to growth of a tiger population, as well as also genetic exchange is a part of the natural process where two population of two different tigers, so when they move around, the genetic mixing happens. It's very very important part of a conservation effort also, and also this area which is a contiguous mixed habitat of both human habitat as well as some and the protected areas, some grasslands are also there, and they're very important ecosystem services, and they also play a major role in the when the prey species, especially the prey species present in these corridors, help when the animal is moving between the two parks. These prey species also plays a major role, and the existence of grasslands as well as undisturbed habitat plays a major role, especially in the animal movement. And also the local livelihood for the local communities. These ecosystems also helps in, other than helping the local communities, it also helps in carbon sequestration, soil stabilization, and water infiltration and watershed protections. Here we use technique like habitat suitable models, where we use prediction to we use a model to predict species occurrence, and using various environmental variables. We use map technology also, input the data from the field, and we predict the area where likelihood the good habitat is available for the wild animals to move around. And we also used many models like cost distance models, Circuitscape models, which I will be talking about in elaborate in what we did in this location, especially to understand how the habitat linkages are there, and what are the potential path for the animals to move between the two protected areas. So in this study, we have used the prediction. We have used prediction models as well as habitat suitability, and also we use cost distance models with the Circuitscape to address the issues which is arising, and also ideas. We have attempted to do some restoration work in these corridors, where I identified those areas where restoration work can be taken, and the habitat can be brought back, so that it also provides a safe passage to this animal. Something to talk about, an introduction to give about habitat suitable models. So again, it's done on a GIS platform, as well as intensive fieldwork and data collection is done from the field. So habitat suitability model, basically, sometimes it's also called a species distribution model, is a method of predicting the suitability of a location for a species or a group of species. There are many models these days they are using, and last 15-20 years this technology and the GIS is used in the wildlife field to predict this. Using this model to predict the habitat suitable and available habitat, how much of habitat is available, where all the species likelihood to be distributed. Such studies has been done. And the quantity, quality, and distribution species present records. These are the data inputs which is required to use this model and predict the available habitat. In our case, we have used land cover, we used elevation, aspect, slope, and various other various other data sets to come out with the results of these corridors. Cost distance model. This also helps. It's one of the models which are used in determining ecological cost of moving between core, let's say two areas, let's say core areas to protected areas, and which is based on the habitat suitability and distance travel. So, like what it gives you is that when you use it in a GIS, this raster is it's a value, let's say call a cell value, where it depending upon the value, how easy the animal or how easily they can negotiate the space and they can walk over. So more the cost, it will be difficult for the animal to it's virtually done basically on a GIS platform. More the cost, it will be difficult for the animal to move through, and lesser the cost, it's easy to move. So it uses those technique, and it comes out with a map, and it gives multiple paths from where the animal can move between two protected areas, or between two forests. And GIS is very much used in these studies, and GIS is one of the important a tool which is used to especially in the field of conservation, to analyze this set of data sets to come out with results. And another technique what we have used here is a Circuitscape. Circuitscape is again a program. Basically, it's an open source program where all these data sets are, where we give us an input, and we use certain we do some technical analysis, and we come out with which are the best easiest way. Again, it's something similar to what a cost path distance least cost path distance model. It's all similar to that. It gives the best clear-cut idea of what is the best connectivity between the two protected areas, or let's say two forest areas for the animals to move on. So it's almost similar. We use multiple techniques in this case to understand clear-cut what is happening between the Satpuda and Pench Tiger Reserve, and how the connectivity is, and what are the land use in between these both the protected areas, how they are affecting or how they are implementing the animal movement. And also we looked into the what are the different land parcels available, which is like whether it is belongs to the forest department or revenue or local village agriculture land, so that we are in discussion with them how they can be helpful. And also, other than that, one part of another effort from a WWF is that we are doing our agriculture team is working in these corridors with the local farmers, for local farmers, especially on doing agriculture which doesn't affect, especially not using any chemicals or anything, so that this also supports the one way, also supporting the farmers to get a better yield. Other than that, also maintaining the habitats and not much disturbance in that area. So they're also putting our other division is also working that to get a ecologically sustainable area where the animals can use those parts. So many multiple efforts are happening in this corridor. We've been last working for 5 years, and Forest Department is one of the major partner in this project. As well as that, also we were closely working the mining department, where many of those unused mine, which we are helping them in using identifying those areas and doing some restoration work with them. And some mines have been closed already, but there are nothing much activities happening there. So those areas we are trying to bring back local species, which can improve the habitat all along the corridors. Yeah. Now coming to the main objective of the study was to look into the land use cover of that area, how the changes happen, and areas those where mining is happening and where the minings have been completely stopped and they've just left open cast mining, and some filled areas are there. Some mines have been filled back, but no vegetation has come over there. So we are looking into those areas where the restoration activity can be taken out. Mainly identify those other data layers we have used. And we use these methods, both the habitat suitability, least cost path, and Circuitscape analysis. And also we looked at the decadal change, how these areas have, what is the degradation, what is the rate of degradation, how much of fragmentation, why this corridor is, lost its actual, like 25 years back, how the corridors were very active, and now due to land use change, how it has impacted the corridor quality. So that also we looked into that. So this is the study area which I was talking about. So if you look at the north of the map, this is a Satpuda Tiger Reserve, which falls also into the Madhya Pradesh, and it continues with the west and east Chindwara. Chindwara is another district, and Pench Tiger Reserve, which falls in the Simni districts. So this is a corridor which I am talking about. So Satpuda and the Pench Tiger Reserve. So So if you look at this, there are many villages all along the corridors. Luckily, some of this part is a lot of agriculture activities also happening, but still some bit of connectivity is still existing, and it allows animals to move across both though 30 years back this was not the condition, but now things have due to over land use change and other agricultural practices, these corridors have been further fragmented, as well as a lot of land use changes happen. But still, it's a potential corridor, and the animal still uses this area to move across. So we are looking in detail as per the study. What are those land parcels where with the restoration attempt can be done, so that the habitat quality can be improved. So this is our study area. If you look at this, is in Madhya Pradesh, central India. So methodology, typical methodology, we used list4 data for this area, and we have used SRTM, and we used various remote sensing techniques to derive the maps. And also we use some models, many models which I was talking about, the least cost path model, as well as Circuitscape and habitat suitability. This is a typical technical flow chart on how this analysis is done. Now coming to the study area, if you look at the map here, So if you look, so you have the North Betul, South Betul. These are the areas that highly like further. It's more of industrial and other activities happening. This is the only part which, if you look at this is the only part still some connectivity is left. So that's the reason we are given a boundary of this, and also it's been approved. It's been already delineated by the National Tiger Conservation Authority of this corridor. So we use this boundary to in specifically to look into the quality of the corridor and the connectivity. And yeah, so these are the various block levels which are across this both the corridors. If you look at it, so many, and it has many villages. Easily there are few hundreds of villages all across this landscape, and they're all well versed with the animals which is around. They know that tiger moves around, they know the prey species, they move around. And though there is one point where completely it is cut off, which we are focusing on that area for some restoration work. And these villages are well aware, and they have been living with this animal for so many years. But now the pressure on this land, especially for the land use, especially in the agriculture part as well as the mining area, has further increased, and the pressure in the corridor has gone up to the extent that last few years, very few tigers have moved between this one or two tigers. In fact, it used a lot of tigers, animal earlier used to move across this two protected area, but now due to this increase in human pressure as well as change in land use as well as activity, very few movement is happening. So our attempt was to see that at least to keep this corridor alive for next in the coming future, so that there could be a exchange of animals between these two protected areas. It's very much feasible even now, because local villages are still aware of that. There is many animals moving between these two protected areas. So if you look at this map, we have forest division boundaries. So we still have many reserve forests in and around this, other than this corridor connecting. There are many other reserve forests in and around, and we have protected areas. This green color, these are the main protected areas still, other than the the tiger reserve. We have other small protected reserve forests available in this area. So still there is a scope for this, and we just overlaid the forest boundary to show you how what is the feasibility of reconstructing the corridors for the animal movement. Yeah, so this is the list for satellite image which we have used. If you look into the I'm sure many of you are aware of how a satellite image looks like. We used which is a 5.8 meter resolution, and if you see along the corridors, still you can see the vegetation connectivity is there. Many are outside. These are the terrain is more of an undulating, Central India being a typical undulating terrain, and still a lot of small natural forest is left, some natural forest still left, and some places some plantation is still happening, and so the habitat is still existing for the animal to easily pass through. Only thing, we need to facilitate the safe passage and identify those areas where this we can do some conservation efforts, so that the animal it makes easy for the animals to move around. Yeah. So if you look at the analyzed image, this is a land use of that area. So we have both sides. The green area up north and south is a protected area, the tiger reserve. Then we have the block boundary. It's actually dense forest. Then we have water holes. All the blue colors are water holes. Then we have so much of agriculture in and around. So this is a critical portion where the corridor connectivity is sort of gone, but still animal use this area, because the villages are in the fringes. Actually, some of the villages are also there inside this area, but less density of villages. So there is still the possibility of connecting this corridor back. And agriculture is happening, but some of the land still belong. We are just working out with the local forest department, and they have identified few areas which belongs to the reserve forest areas, or which can be restored, and some of that. And within this corridor, there are few places where open mining was once happening. Now it is closed. I'll show you a separate map on that. They're very small, though, at the scale it looks, but those are the locations, areas where no activity is happening of mining, and they have a huge uh, mines which is like left unused. So those are the areas which can also be taken into consideration for restoration work. So this is typically the land use map of that area, and we are talking about this entire this stretch, which is around 40 to 50 kilometers of stretch. So we have used the digital elevation model of 30 meter to understand what is the terrain in that area. So if you look at the maximum height comes in Satpuda, which is around 1,300 meters roughly. And also in Pench, we have some, Pench also has some elevation, which is around 700 meters. And also we calculate through C. These are the different layers input which goes into the model for the calculations. So if you look at the slopes, if you see some very slopes are these areas where the undulating terrain it will be high. Otherwise, it's more of a gentle slope, around 10 to 30% degree is the slope overall in the landscapes. So it's more of a smooth, for the animal, it's easy to move around. So under the methodology where we use for the cost suitability, there are various layers which are used. We have used LULC, we have used digital elevation model, we have used slope. Along all the villages, we have kept an around half a kilometer, 1 kilometer buffer we have drawn around, so that they are all they don't. It's not easy for the animal to move around, and they cost very high for the animal to go closer to that. Then we have done the roads, and we have also one railway line is there in that area which crosses across the corridor. And based on this analysis, this is the cost suitability area. So based on it also, if you reverse the cost raster, it is the habitat suitability basically. So this is a map which we get as an output for that, and those are the paths, and I'll show you the next. So cost suitability and source and destination. This is a typical software-based analysis, and you get the output out of it. Based on this analysis, this is a least cost path. So you have multiple paths which can, based on the cost raster, the animal can move, or they can easily negotiate, or they can use. But on the ground, situation is very different. This is typically based on the analysis we used on the desktop or else using the GIS. So where the animal can use these paths to cross through and reach, Satpuda-Pench, or from Pench to Satpuda, vice. And now, even here, if you look at this certain places, still the animal can, if they are using, they have to reach up to this place, because again, these are the best, stepping stone sort of thing. But again, a huge agriculture land in this area does not allow the animal to easily to pass through. So the only connectivity which we got through was easy to go. Continuous connectivity was this one single. So the corridor which is earlier marked, the outer boundary of the corridor is perfectly matching with the analysis also. So this gives an based on the least cost path, it gives an connectivity between these two. Though there is, as I said earlier, there is some, these are the places, some locations there are some issues. It doesn't connect properly as such as a habitat, but still the animal can use it. And the results also show there are multiple paths. So this is one of the analysis which we did. And when we enlarge it, if you see I was talking about the mining industries. There are few mining industries which is here, close by here, very close by. Activity is still there. There are some mining areas here also, but they are closed. This one is a closed one, but these are still active. So if you look at this, is the best, connect, and this width is around 1 to 2 kilometers maximum. So this is still a feasible corridor which can be reconnected for the animal movement. Animal movement still now it's happening, but it's our effort can increase, or it can facilitate more exchange of animals between these two protected areas. So this second one analysis, what we did was we wanted to understand that we used one more analysis that is Circuitscape, to see the connectivity and see how they are, how this again it also gives a similar results, how the path are connected. And they used between two between two protected areas. It's a typical one GIS analysis where we used here the concept of Circuitscape is using resistant layers we use, where it's like similar like a circuit, current circuit, where wherever the connectivity is there, the current will pass through. So based on typical that concept, this model is run. It's a typical voltage map. Based on that, we have done this. The Circuitscape software, it runs analysis based on those layers which I've used earlier, which I've shown. And this is a software which we used. And this is an output you get. So if you look at this here in this map, it also represents similar like a least cost path. The connectivity is a multiple, current passing through, and the best path is again, it similarly follows the same least cost path. So this is just to double confirm that whether the earlier analysis and this analysis do they say the same thing. And interestingly, again here, if you look at this, there are the current passes up to this place, but again the connectivity is gone. That is, and again all this matters based on the input data what you give. The quality of input data is better, always your results is going to be it gives a clear idea. And also the ground condition, you have to do a lot of extensive field work to understand what is on the ground. Always what map is represented based on the analysis cannot be taken as such. We did a lot of field work to understand what is on the ground, and how much of our map work, desktop map work, as well as the prediction of habitat quality and habitat suitability on the ground was matching. There are some places, of course, like these core areas within the corridor which we marked, matches a lot, but outside it's not really. It's not the situation. It's very worse. Though the map shows that there are some feasibilities that on the ground, that is not true. It's like total agriculture area and a lot of human dominated landscape. So this is the only part and hope which we have for the future, where the connectivity can be restored further. So this just more representation of the same corridor what we have done, what we have analyzed, and we have overlaid a few other layers to understand the extent of the corridors and the length of the corridors, as well as the administrative, how administratively it is feasible. And we have been talking with both all the district, local district forest department, as well as both DFOs and the forest officials are involved, because they have to be brought into the board to get engaged, especially identifying those areas where the restoration activity can be taken up. And also we are involving mining department also. So this is one which we could understand that we can have the connectivity. There are few areas where we have to zoom in and understand what is the land use there, what is the owner of the land ownership, as well as also the situation on the ground, so that we can take up. We already started up the first phase and we are into it. So we identified a few areas which we'll take up in first phase, and phase 1 and phase 2. So I'll be going to that. So if you look at this, there are multiple paths. So based on the Circuitscape was coming, but we were considering only this as a potential path where we can put our effort in restoring the corridor, so that animal can pass through both the across both the protected areas. These are we're not considering this area because of they can we can't have so much of effort, and as well as on the ground condition situation also doesn't allow us to restore this area. It's gone. It's more of agriculture and human dominated area. But this part is still feasible. So we have now divided this into various phases. I will show you. So this is the first, probably one of the area which we wanted to zoom in to look into this area, what is actually on the ground, and we had used a 1 meter resolution to check on the ground and what is the situation on the ground, and how much of area is available, how much forest connectivity actually on the ground, because each scale will speak differently. So at 5-meter resolution, we could get that. We are zooming into 1-meter resolution, and these are some of the maps which I wanted to. So we have gone into the district level, block level, and village level maps also. We have overlaid to see what is the situation on the ground, and how we are talking to the villages also, local villages, how they can be engaged in restoring this corridor, because they also understand the importance of animal moving between these two protected areas. Yeah. So now we have further went into the mapping of non-forested area, which is a gap actually. So if you look at this is one of the critical disjunct of the corridor, and this is one of those. Still, there are some forest compartments are left. So this is the only hope we have. So we want to establish the connectivity. So the villages are outside. Some villages are here. So we are talking to them. These are the areas which we identified based on our analysis. So if you look at this yellow, or the gridded yellow, these are the patches which are still open, gap areas, and rest the green color, the light green color. If you look at the light green color, these are the forest, still the protected areas, and reserve forest. So it's still under the control of forest. So this is the main portion where even some small parties of mining, so which is mining is stopped. So we are working in with mining department, and restoration as activity has already started in this area. But these are the place where we are looking how to engage with the local villages, and many of them not typical in agriculture area. There's lying the land, open land. They're not doing any agriculture in there. So there is still, we are planning to use those with along with the villages as well as the department to do some plantation work, so that the connectivity or the habitat can be improvised for the animal to move around. So this is based on the detailed analysis of 1-meter resolution we've used. And we have again classified that we cannot take the entire, around 40-50 kilometers. We cannot go in one go the activities. So we have prioritized into various areas 1, 2, 3, 4. So if you look at the dark red, so priority area 1. So this is the portion which we are now extensively working with the department as well as the villages and panchayat area, so that they can re-establish some of the activity using restoration activity, and re-establish the corridor. And last 1.5 years we have started to work along with the villages, and we hope that in a long run, 5 to 10 years down the line, these areas will be a little better vegetated. In fact, 2 to 3 years down the line also it should happen. And conservation, tiger conservation, or even a corridor, it cannot happen just by not only by the department, the locals. It has to be community participation is very, very important. So that's one thing, a great lesson. We know that that's how it has to work. But when we are working in this project, we come to know that what are the other issues they face. Though we are only focused on consumption, but they also have many other issues. Convincing local communities to take part into it's one of the biggest challenge. So if you based on this, like our priority, so the colors, if you look at the colors, so priority areas, this will be the second priority area, though it's a better place. So first, the reddish, the most priority area 1 is where completely it is, it's a devoid of vegetation. So that's the reason we have taken these areas. Few parts, like here also there are a few bits and pieces here also. So, and the next it's a priority area 2, which next year we'll be looking into slowly, and priority area 3 and 4. Okay, now and also this is another map again. Another map where if you look at this as some part of mining, though it looks very small. Many mining still. These are the areas where mining activity is still on. There are new mining going to come up, but luckily they are not into this space. But this area is already closed. This mining activity just closed 2-3 years back, and it's an open cast mining, and they are filling it up now. And so we are planning to take the activities on the restoration activity in this area. And there are few small spots. If you see, these are all closed mining. So these are still some hopes we have that the restoration activity will be successful in the long run. And this all for feasible or possible, I would like to say, using these techniques. So that's one of the important I would like to emphasize in the talk, is that how these technology of remote sensing, GIS, and supported by the field work helps in identifying, especially in the corridor. There are many corridors in this country. There are like elephant corridors, separate tiger corridors, is like animal park. Many places throughout the pan India, if you look into that. But all of them have the same similar issues because of development activities, fragmentations, as well as human pressure, agriculture, land use change. These are putting a lot of effort, a lot of impact, as well as they are affecting the corridor connectivity and also development activities these days. Right, and many places, if you see the new mining coming up, they are going to impact in these corridors. Wherever the corridors are there and the connectivities are there, they are going to go impact in and that in turn is going to increase the human animal conflicts pan India. So that's one of the reasons that why corridors are very, very important, not only for the the genetic exchange, but also for the animal to wild animals to move across to protected areas, or and for the long term existence of their population numbers. It's very, very important, because if they are not going to move across and they're going to remain in the same place, then in a long term it's going to affect their genetic quality as well as, and that's going to impact their population in the long run. Now, we also did some bit of other analysis like fragmentation to see how this fragmentation has affected, what are the core areas where the perforation is happening with the present situation, which has helped us in identifying those priority areas. So we have done also this analysis, and these are some of those main characters which were looked into, main features which were looked into the fragmentation, like core, perforated, edge, and patch. These are important elements within the fragmentation. We need to look into that so that we understand what is the present condition, and if it's going to be highly fragmented and multiple fragments are there, it is going to be very difficult, especially the restoration efforts. So we need to understand. So this sort of analysis helps you in understanding what is the present situation of that area, specifically. If you and how we can scientifically, and we can take a decision of at the policy level or at the implementation level to improvise condition of on the ground. So especially in this corridor, we have done this analysis to see what is the situation, and especially with the forest patches. Even forest patches are getting degraded because of the human pressure in and around the corridors. So we used to understand how the area is especially in that if you look at this part of the north part of the corridor, which is highly fragmented. So we done an analysis to understand what is the patch size and how how much of core forest is still left, and what is the perforation, what is the size of the perforation, all those things, to make a better understanding of and the quality of the corridor. So this is some of the maps which I would like to show how connectivity as well as and for forest fragmentation, and what is the rate of the extent and rate of perforation in that area, and also edge forest, so due to the perforation and fragmentation. Okay, now also, as I mentioned earlier, that we also looked into the decadal change. What has happened last 15-20 years from 1990 to till 18 or 17. We wanted to look into what was the situation in that area, how these changes happened. So if we look at in 1990, how much of dense within this corridor boundary. If you look at the dense forest and how much of open forest and scrub forest and water bodies, what is the change among these important features? Because we didn't want to look into other features of the land. Mainly, these are very important for a habitat point of view. So we looked into this land use classes, and in 1990, this is a situation. Like if you say dense forest, it was around 1,065 square kilometers. Like if you look at into 2000, almost 10 years down the line, it was 804, and in 2016 it was 615. So almost within this, this I'm talking about within the corridor patch. So if you look at 1065, 805, 615, so this is a rate of change. And if you look at the scuff force, is also like, initially it was down, increased further, and it's like, it's also going, it's further decreased actually if you look at this. And water body is also sort of like increasing, because many of the activities of the villages, they're digging some ponds, and also the the open mine area which is abandoned now is full of water. Those things also contributed to the water body. But our focus was mainly on the dense forest area, which is completely like, it's like decreasing a lot in last 25-30 years roughly. So overall, within the corridor, if you look at that, what is the rate of change? If you see how the dense forests has come down from 1,000 to roughly 600, 615. So this is the rate of change in 30 years roughly. So 27 years, in fact. So if this is going to be, and of course, a lot of plantation activities happening, as I said earlier, with the reserve forest area, that's helping us in, improvising. So this is again, hopefully we hope that restoration effort, what we are putting in next 5 to 10 years should show up, and it should increase, at least a forest to the area, or the habitat for the animals to move. And again, scrub forest degraded. If you look at it, initially it was low, then it increased because of, this is a effect of this. It's decreasing here, but they are again becoming degraded, and scrub forest and water bodies almost remains the same. So for our restoration work, this is if you look at the map, we are this is a phase 1 which we are looking into. This is this portion which is a phase 1, and we have site 1 and site 2. So site 1 is one which is presently the activity is already started, because this is a gap which is having major gaps, and connectivity has to be done. So if you see, these are the villages. We are already in discussion with them in collaboration with forest department, mining department, as well as the local plantation. They have the forest department which looks into the plantations. We are also working closely with them, so that these are the areas where initial effort is going on. We already started this last year, and next year the site 2 will be there, and again the phase 2. And phase 2, these two portions, though there are still some existing good habitat is there. So this will be the phase 2, but this is these two are the areas which are looking where, and the restoration work has already started. And that's how, these tools, as I said, the tools, analysis, field work, all helped us initially to. It took us 1.5 years to do this analysis and understand what was happening in this corridor, and also a lot of stakeholders like forest department, local villages, communities, mining department. They were all included, and also, as I said, our WFE, the agriculture departments, looked into the sustainable agriculture in this area. So they are closely working with more than thousands of farmers in that area to not to change their crops much, and so more and more land uses also causes these. Habitat quality as well, because animals have now started using a lot of this agriculture feed also. So disturbance is going to be less if you are going to keep changing changing the crop patterns. Also, those also will affect in the long term the land use changes. So we are working closely with them also so that they don't change their crops much in the long term. And so various efforts and various restoration and conservation effort has been put into this corridor. Hopefully, we hope to see that next 5 to 10 years, these corridors will be very actively, animals back. They'll be back to. If you leave with this, many of those areas, if you leave, the natural vegetation comes back, that also will help the animals to use those areas to move across both the protected areas. And Satpuda and Pench tiger reserve, they have very good density of tigers. So it's very, very important that these corridors connectivity and the corridors has to be connected, as well as has to be actively used by the animal with less disturbance and good connectivity, and they are able to move across both the let's say the tigers as well as their prey species. So if we also calculate how much of area of restoration area we'll be taking into. So priority site, if you look at the forest block, is almost 18.9 square kilometer. But this is the area 2.35 priority 1, 2, 3. These are the areas we are looking initially. So much of area will be covering under our restoration effort. So this this is a level of analysis which we have done, and or planned activities for the next 2 to 3 years. And side 2 also, so each block wise and each area at the local we have calculated this, and as priorities we have. This is little larger, 61 square kilometers, 73. So this is a side 2 area which will help us. So if you look at, these are the areas which already we have identified where this is an area which has been identified where the restoration effort will be taken into. So more focused, so that we can see the results in the long run. So this is again very much feasible and possible because of these techniques available, technology and technique available in the field of GIS and remote sensing, helps us to understand the corridors and their functionality as well as the status far better. So 40%. So conclusion. This is just about the that area, how the forest has happened. More than 40% of the total area of forest is covered. So that gives a hope that corridors is still, and the rest of the area. This is I'm talking about along the corridor, and that boundary of within the corridor. 37 is agriculture, and we have open barren and barren without least vegetation cover, 90% roughly. So these are the least vegetation cover. Some we are looking into the land holders, depending upon whether it is a once a reserve forest, or let's say it's close to a reserve forest, or it is unused land by the by the local villages left barren. So those are the areas we are focusing, especially for the restoration work. So if you look at the just is that what's happening is forest from 1990 to 2017 within the corridors and along the corridors has come down. That's major, one of the important observation, which also has contributed to the further, because of pressures of the villages, the land use change, as well as the mining activity has further damaged the corridor connectivity and fragmented the habitat. So that's one thing which, and we are able to use this technique to understand the present situation of the corridor and what's happening and how it can be, how the restoration work can be taken up in more scientific way and address the issues. So that was about overall my the specific corridor. We have done many corridors, but this was one of the interesting and work which I wanted to present to the NVIS team. So thank you for the opportunity. I would like to take some questions.
Thank you so much, sir. Sir, we have few questions. I'll just read out to you, then you can answer them.
Sure. Yeah.
So the first question is, sir, please explain how to obtain weights for slope, village buffer, railway buffer, etc.
How to obtain? Sorry, I didn't get. What is that?
Explain how to obtain weights.
Up to weight. Okay, weighted overlay. Okay.
Right.
Can I? Who's that person? If they can send the email, I will like to send an email and discuss it rather than because it's more technical. I don't have anything to explain here on the screen, but I would like to.
It's from Chandan.
Give them an answer over an email.
One of our colleagues, Chandan has messaged this. I think I'll forward your mail to him. So we'll take up the second.
Yeah, you can first forward my email. Yeah.
Okay. I'll take up the second question by Sharanya. Sir, may I know what are the strategies or critical factors considered to decide upon the least cost path? Also, who are the stakeholders involved in deciding the same?
For the least cost path.
Yeah. What are the critical factors and strategies involved?
Okay, one of the least cost path analysis when we did, especially in this case, was that so for the least cost path we have used all the layers which I showed to you earlier. Those are the variables which I've used, especially the least cost path and also we have got some data from the field and the animal movement locations based on the human. What are the different let's say tiger is one of those. Their presence data we have used for. First, we created the habitat suitability, the PAMP for that area. Then we based on the various other layers, we have given the values, overlaid values to them, and use overlay value overlay weighted overlay we use for each layers. Based on that, we have calculated this. Other than this, we also had a discussion local. Other than it's actually done in the more of in the lab, but we had a discussion about this with the stakeholders like forest department as well as mainly forest department and the local park people. As villages were not involved in this at all because they will not be of much useful. But of course, villages were interviewed by this data was provided by some other NGO actually. They've done some camera trapping in that area also, and also some villages were interviewed to understand what are the prey species and how the animals are moving in that area. If there's any location, if they've seen recently sighted, all those things also have been taken into an account. So when you least cost path, especially, it's all based on the basic layer is your land use land cover of that area. So you give that also forms main important input for your habitat suitability as well as to run the least cost path also. So earlier, if I can go back to the slides, if you see what are the different layers along with the LULC was that these are the layers which I've used along with it, where each variables has been given a different weighted overlay values, and we run it. Yeah. But if you look at these are the layers. In my case, we have used it. If you look at this, TM, village buffer, weighted road, and weighted. So this is what we have used. Other than land use, and each land use class also like forest. Forest also will have a value. Non-forest will have a different value. Water will have a different value. So this is how it is run. Yeah.
Okay, sir. So the next question is, what is the main reason for fragmentation in core areas, and how will you restore it?
What are the main reason? Yeah, as I said earlier, that the core areas here, if you look at the protected areas, of course, also see here the Pench Tiger Reserve, which is in the southern part, and if you look at the Satpuda, which is in the northern area, they don't have much of impact, especially with the fragmentation. But all the connectivity in between, they have this problem, especially. And on the ground, what was the situation is many of the these let's say honestly, we should accept that some of the reserve forest area also has been touched by the locals. They have been clearing the forest locally for the wood, for the daily wood needs, and also some of the area has been been occupied and they've been taken for agriculture and all those things. So those clearance, and last 30 years, if you look into that land use, if you look at the forest, how the core forest is the dense forest has become secondary forest is because of the human activities. They've been cleared, and a lot of land. Other than that, land use change, especially with agriculture practices. A lot of areas been under agriculture now. Newly, the forest has been cleared, and we started using for agriculture also. That is one of the main reason, especially those core areas. Slowly they are getting the perforated, and this wherever the protected area boundary, not much problem. But just outside the protected areas where some reserve forest patches still left, the density of trees have gone down last 30 years. Because I worked in that area also before for my PhD, I've seen that area very well. What I saw in 1990s and now recent visits like 2017-18, I've seen those patches of forest which is outside the protected areas. Their density of trees have really gone down. They've been felled, or they not maintained, or it's been cut. I'm sure it's been used for local villages. So they are also contributing in the map for those perforation, especially core area going. And how to address that? Only easiest way is to go for a restoration work in those patches. That's the reason we have identified few of those, wherever feasible, with the talk with local forest department as well as the villages. We identified those patches where the restoration can be taken up fast, so that these areas the habitat can come back to the original situation, at least next 5 to 10 years. Yeah.
Okay, thank you, sir. So the next question is, once the least cost path has been identified, are there any monitoring studies carried out in consequent years to know if the animals are taking these corridors?
So last 2 years, see, we have, I told you, this happened to 17-18, we have done this study. So last 2 years, this year anyway, 6 months is gone. We couldn't do much in last 6 months. But before that, we had started the restoration work there. So we are yet to see how whether there is any change in that. We have not monitored that actually after the restoration ecology after the restoration work started. We have not looked after that actually. We couldn't have much, but the activity of plantation and other activities still continuing. Hopefully, we should again visit and see, or maybe a camera trap and all those things will help us in knowing whether the animal is using. But habitat improvement, it will take some time. Many of those identified priority areas are in really very bad shape actually. So it is going to take us larger in the long run, probably 2 to 3 years down the line, the restoration activity. But I hope that once the restoration activity is finished, then we'll be able to actually monitor and see whether it has impacted in any way or helping the animal to move across. Yeah.
Okay. So the next question is, while there is no doubt about the study and analysis of such corridors are important, apart from satellite and GIS fieldwork, are there any newer technologies that can be tried out in order to monitor human-animal conflicts?
Well, WLF, we have been trying many. One is that I would say, these days, very advanced, in the sense, advanced warning systems have come in, especially if you look specifically if you want to address a human-animal conflict. One is that advanced warning systems have come in, especially for elephants. These days, they are using, in Tarayark and some in Assam. Some of our work they use these systems. They are using. It's a technical where it gives an alarm in advance when if the animal is coming closer to the village, and they're using many places. They're using these days, especially I've heard from Valparai that. They're using mobile technology, especially using through messaging that if animal is moving in certain areas, they've been informed to the locals that an elephant is moving around. One is that you can put a collar to the collars, satellite collars or something, which we can use actually satellite collars for the, let's say if it's a tiger or elephant, and we can inform in advance to the villages or to the locals. So there are many techniques available. We have to, because in future technology is one solution which is going to be very very highly dependent going to be highly dependent by the even by the forest department as well as the public. They are going to get into it actually. That's my opinion. Yeah.
So the next question is, do such corridor projects also help reduce land and animal poaching?
Sorry, I didn't get you the last word. Sorry.
Do such corridor projects also help reduce land and animal poaching? Basically, animal poaching. Does it reduce animal poaching?
Yeah. Okay. It's very difficult to say that, but poaching is absolutely a different. It's a different situation actually. Whether it is a corridor or not, even within, poaching does happen if the animal comes out of the protected area. There are some places I heard that even within the protected areas, poaching happens. Poachers, they don't have any boundaries. They can go within protected areas and they can hunt anything. But corridors, of course, is one of the vulnerable place where animals get poached often. And if it's going to be a very very let's say perforated, or if it's going to be a very highly degraded corridor, of course that will facilitate the poaching. But poaching is it doesn't have any limitations. I said it, whether it's a corridor, it's on the inside the protected areas, even on the fringe of protected areas, it's going to happen. Animal once comes out, and if the, let's say, tiger, or for that matter, if it's going to come out of the protected area, and if there is a highly human dominated area, it's going to be poached. So there's nothing like corridor is contributing to the poaching or anything. But corridor, if it is going to be highly fragmented and no way the animal has to pass through between two places, and if they're using that corridor, and if the it's very much it's easiest way to poach an animal in a corridor rather than in a protected area.
Thank you, sir. I think there are no more questions. So I would like to thank our speaker today, Dr. Gopala Arindran, and for giving us such a insightful information on wildlife corridor. So I hope all the participants have been benefited by this talk, and I thank you once again, sir, for being part of this. Sir, sorry, there is one more question. One last question. Is any procedure of village rehabilitation in these areas? Are there any procedure of village rehabilitation in these areas?
Well, it's a bit difficult because if they are all our revenue villages, I really doubt that it's feasible. Until if it's a villages in the fringe of inside the protected, let's say in a tiger reserve or in the within the boundaries of tiger reserve or protected areas, the forest department can take up, and there are many policies where villages have been rehabilitated within the protected from the protected outside. But these are all, many places are within, they're in revenue villages. I don't think so. Revenue villages, it's easily feasible today's world, to relocate them and buy that land and restore corridor until the entire villages or few small villages within these corridors, if they are ready to go out from there. But they're all highly agriculture areas. They've been working, they are practicing agriculture for the last 20-30 years before they illegally occupied those lands. So it's very difficult now to remove from them from those areas. So it's not going to be that easy. But of course, within tiger reserves, there are schemes where tiger reserves do still relocate villages from the protected areas. Yeah.
Yes. So I hope that answers Draupadi Yadav's question. And are there any more questions? Okay, sir. Thank you so much. Thank you for being part of this webinar session and delivering a really informative webinar. And I thank all the participants. So I think of whatever the questions are coming, I think I'll correspond to you through mail.
Please. We'll share can you send me email the first? The first question, yes, I would like to send him the details. What we did, it will be easy for him. Chandan, Mr. Chandan. Yes. Yeah, sure. We'll have to. Yeah, please. Sure.
Thank you. Thank you so much.
Thank you. Thanks a lot. Yeah. Oh, it's my pleasure. Yeah. Yes.